Alright, hello everyone, it's September 15th. Alright, let's see what we have today. Replace none co-prime numbers in an array. We're given an array of integers. Perform the following steps. Find any two adjacent numbers in nums that are not co-prime. If no such numbers are found, stop the process. Otherwise, delete the two numbers and replace them with their least common multiple. Oh shit, how do I do least common multiple? Ugh. I think it's to find their least, no, the largest common divisor. Yeah, we find the largest common divisor, greatest common divisor, right? And then you multiply them together, divided by that you get the least common multiple. Repeat this process as long as you keep finding two adjacent non-co-prime numbers. Return the final modified array. It can be shown that replacing adjacent non-co-prime numbers in any arbitrary order will lead to the same result. Test cases are generated such that the values in the final array are less than or equal to 10 to the 8th. Two values x and y are non-co-prime if GCD is larger than 1. So I have to find GCD, right? I have to find GCD of two numbers. And then if they are not co-prime, then we have to swap them, because this GCD is 2, and 4 times 6 divided by 2 is going to 12, and then into 12 and 3. 12 and 3 will be 3. 24 divided by 3 is 12. 12 and 6, that's still 12. So 12, 6 is done. Then you do 6 and 7 is done, and then you do 6 and 2 is going to be 6, and that's it. So I don't know if there's anything tricky in this. You just need to do GCD of tons of numbers. There is a concern that you might be redoing the same GCD over and over again. So we might need to, I don't know, maybe have a map, but the map will be what? A and B and B and A, and every time you find it, well, we can just do A and B. So A, B, give me a new number. I am not sure if that, because GCD is pretty fast. Do they have GCD? C++ GCD. GCD. We might have to write it ourselves. We don't. They have a GCD. Or you can do that yourself. Yeah, A mod B. So if A is smaller than B, it will return A. Alright, A is smaller than B, return A, so I basically swap. And then you get the remainder to this, and then the divisor to this, and up until the end, where this is 0, then you return A. So I don't know, we can try. Just, straightforward. If it times out or whatever, then we'll read the hint. I don't know. I mean, that's the thing. I have no clue what it's trying to test just by looking at it, because once you handled a pair, you don't have to. Oh, that's the part. Once you handled a pair, you say, okay, they are co-prime, and then you go move on to the next pair, you might change, right? So if they change, it will be the least common multiplier. So if I have a co-prime, if A and B are co-prime, right? If A and B, if they are co-prime, and B and C are not, then we'll do something with B and C. So we'll find a least common multiplier. So it's guaranteed that it's larger or equal to B, right? So if A and B are co-prime, now you find something that's bigger than B. It is possible that it becomes not co-prime anymore. Example 2, 3, 6. 2, 3 are co-prime, 3, 6 are not. So this one will go to 6. Now 2 and 6 are not. And then you go back and forth, back and forth. So then what? You have to go through the whole thing, come back, redo it, and then come back, redo it. That seems to be timeout material. Huh. It should be like if once 3 are done, now we move on to the next one, right? Then these will not change. That's actually not true, because when these change, it might affect this, and then it might affect this. Yeah, so it's still going to have an impact. Huh. Are there a number that once it's changed, it will remain unchanged? So yeah, if the first number is larger than the second number, then we can guarantee it will not change. It's always gonna be bigger than the current two because it's least common multiplier, right? So it will be bigger, and then so once you change, it will become a bigger value. Now this bigger value, it can affect the one in the front, right? It can affect the one in the front. It can affect the one afterwards. I think brute force definitely is not going to work. Let's see the hints. Order does not matter, so we can greedily merge elements to its left if possible. What do you mean by greedily merge? So there should be a certain order we follow if we want to merge. Do we merge the biggest one first? I don't know what it means. If a new value form, we should recursively check if it can be merged with a value to its left. The value to its left. I don't understand. So you're saying I got 2, 3, 6. We handle this. Then we handle this. Then every time it's coming in, I just handle it and then push it in, handle it. What were you worried about earlier? What I'm worried about is I do the next one. Then once I do it, I have to do the one back. So what this is saying is every time you do it, you just keep going this way. You make sure everything that's in it is all good. So that means every time you do it, you only do it once. Then this is no different compared to parentheses. Right, it's no difference compared to parentheses. Use a stack. Then the problem become the same as pairing parentheses. Yeah, I wasn't thinking about how, I was thinking about going to the right. And then you say, yeah, you have things on the left. But if you do on the left, I think things will be much easier. Okay. And then we will do, for int n of nums. Right? This is a new one. And we say while stack. So while stack.empty, right? If a stack is not empty, we just take it out, or pop it, do it, pop it, do it, pop it, do it until it's then we push it back in. Actually, I think it will be easier. Let's do this. Okay. It's an int g gcd st.top and current. If g is larger than 1, right? Then we say current shall equal to st.top times current divided by g and st.pop. Yeah, okay, the new thing, and then we try until else if it's equal to 1, then we'll break it out. Right, once we break out, we'll say st dot push current, and then at the end we'll return vector int st dot begin. Oh. through this. Back. Back. Hop back. Push back. Is that it? I guess that is it. Okay. I guess I don't have to do this. Yeah, I don't understand. I thought it was more complicated. It turns out it's just the same. Yeah. That was definitely a miss. I think you should be able to do this by yourself instead of reading through the hints. Yeah, I'm a little bit disappointed. I thought it was... I didn't realize you can go to the left. You know, why don't you go to the left? Alright, anyway.